All right. Hello, class. I am pre-recording this lesson today. So I'm recording this lesson on a Monday, and this is for Tuesday. That is because I'm going to be taking Tuesday off to write to finish writing the finals for some of my other classes. And plus we only have half an hour to be together, so it just seemed like a good day to just take off. So I'm expecting you to watch this lesson on Tuesday and submit attendance at the normal time. There will be no substitute teacher. You watch the lesson, you submit the attendance. If you don't submit the attendance, I will mark you absent. And if your parents email the attendance office and say, but my student says they were there, I will say, no, they were not there. They did not fill out the attendance form. Okay? So the expectation is that you watch this and you submit attendance at the appropriate time. But there will be no substitute. All right. So, what we're going to be talking about today is something that I think is kind of neat, which is bitwise operators. Okay? Bitwise operators. It turns out that it is possible in Java for you to express an integer as a binary number if you define it using the correct terms, which I'm going to show you in a second. So this whole lesson we're going to be dealing with two integers, which I'm going to call x and y. So x is the integer represented in as 101011 in base 2. Okay, so what is that equal to in base 10? Well, it's going to be 1 plus, because this is the 1's place, this is the 2's place, this is the 8's place, and this is the 32 place. So it's 1 plus 2 plus 8 plus 32. And that's 43 in base 10. Okay? The second integer, which I'm going to call y, is 110001 in base 2. So it's going to be, this is the 32's place, so 32 plus the 16's place. 32 plus 16 is 48 plus 1 in the 1's place. So that's 49 base 10. Okay? And that is equal to 48 plus 1. So if I wanted to express it in hexadecimal, it would be 31. Hexadecimal is base 16. Okay? So if I wanted to, I could, in my Java program, I could write int x equals 43. But, and there's this, you can define it as a binary number if you do the following declaration. You put int x equals 0b. So 0b means the integer that follows is going to be expressed in binary. 101011. Okay? So that will do these two expressions will do the same thing. Okay? So 0b preceding a binary number tells the compiler that this number is in binary. It's not 101,011. Okay? It's in binary. Similarly, you can also define numbers in hexadecimal. So I could say int y equals int y equals 49. Or if I wanted to express it in hexadecimal, I'd say int y equals, and instead of 0b, you do 0x 31. Okay, so 0x tells the compiler that the number that follows is in hexadecimal. Okay, so you can basically define variables in that way, so it's kind of nice. Okay, so now there's a couple of cool operators. Okay, so if you do system dot out, hang on just a second. If you do system dot out dot println, x, all right, that's going to output to the terminal 43. But you can force it to be in a different base, okay? And it turns out that there's an integer method, and it's integer. It's a static method of the integer class. Integer dot toString, and then we would feed in the integer x and then the base that we wanted in. Okay, so if I did system dot out dot println, and then I did integer dot toString, and I did x in base 2, then what that is going to print to the terminal is going to be 0, 1, or sorry, 1, 0, 1, 0, 1, 1. Okay, so it's gonna print it out to in binary form. We could put in 16 here. We could print things out in hexadecimal form. All right. So let's go ahead and define some what are called bitwise operators. So what if I said x side, or I guess greater than 2? You want to think about this as, so this is the bitwise shift operator. So this is the shift right operator. Okay, so what it's going to do is it's going to take 1, 0, 1, 0, 1, 1, and it's going to shift it to the right by 2 places. Okay, and it's going to pad, because when I shift to the right, it's going to fill it in with zeros. Okay, so if I shift this to the right 2 places, I would get 1, 0, 1, 0, 0.11. Right? So now this is behind the decimal point, but it's just going to drop those. Okay, they get shifted away to oblivion. All right, so this is going to be the answer: 0, 0, 1, 0, 1, 0. Okay, I could just decide to shift 1 space. So, like for example, if I decided to do x shift right 1 space, then that would be equal to this shifted 1 space to the right, which would be 1, 0, 1, 0, 1. Okay. There is also a shift left which is less than. So that's going to shift the string of bits to the left by one space. So this would be 1, 0, 1, 0, 1, 1. And then it's going to shift it to the left and fill it in with a 0. Okay. So one of the uses of these shift operators is instead of dividing a number by 2, if you think about binary, dividing by 2 is just like dividing by 10 in decimal, just takes all the digits and shifts them over by 1, or multiplying by 10 shifts everything by 1. This is a way of dividing by 2 or multiplying by 2. Okay. So those are examples of what are called bitwise operators. And there's some more. Let me just copy down what x and y were one more time. 1, 0, 1, 0, 1, 1, 0, 1, 0, 1, 1, and y is equal to 1, 1, 0, 0, 0, 1. Okay, so we learned about the logical and. So the logical and, which is in Java, it's the 2 ampersands, one after the other. Okay, but then there is also the bitwise and. Which is just a single ampersand. Okay. So what that's going to do, so if I did x single ampersand y, okay, that's going to take these two and it is going to take each bit and AND them with the corresponding bit. Okay, so 1 and 1 is equal to 1. 1 and 0 is equal to 0. 0 and 0 is equal to 0. 1 and 0 is equal to 0. 0 and 1 is equal to 0. And 1 and 1 is equal to 1. So that is going to be the result. Okay? So you're taking each bit in x and each bit in y and you're ANDing them individually. Okay? Similarly, we learned about the logical OR. The logical OR, so like true or false is going to be equal to true. And that was equal to the double vertical bar. Okay? But similarly, there is a bitwise OR, which is just a single vertical bar. Okay? And so what if we did x bitwise OR y? That would be 1, 0, 1, 0, 1, 1, and we're going to OR it with 1, 0, 1, 1, 0, 0, 0, 1. Okay? So what is that going to be equal to? 1 or 1 is 1. 1 or 0 is 1. 0 or 0 is 0. 1 or 0 is 1. 0 or 1 is 1. And 1 or 1 is 1. Okay? So that would be the result of the bitwise OR operation. Okay? And there's one last, which is the bitwise exclusive OR, which is the caret. So remember, exclusive, the regular OR is 1 if either one or both is equal to 1. But the exclusive OR is only going to be equal to 1 if you have a 1 and a 0, or a 0 and a 1. But if they're both 1, it gives 0. Okay? So what if I did X bitwise exclusive OR Y? So I have to take these okay, and I have to go bit by bit in exclusive OR. So 1 XOR 1 is 0. 1 XOR 0 is 1. 0 XOR 0 is 0. 1 XOR 0 is 1. 0 XOR 1 is 1. And 1 XOR 1 is 0. Okay. So what we are going to do is we are going to switch to give me a second here. We're going to switch to the Genie and show how all this works. Zoom in a little bit. Oh, I forgot one operation before I do that, which is the complement operation. So if you do squiggle X, that's going to reverse every bit. So 1, 0, it's a bitwise not. Okay, so if you did squiggle 1, 0, 1, 0, 1, 1, it's going to reverse every single bit, and it's going to give you 0, 1, 0, 1, 0, 0. Okay? Okay, so now I can go to okay. So first off, I want to show you that this method of defining the integers works. So here's X as we define in class, or on the piece of paper, and here's Y. And let's just print out X and verify that it is going to be equal to 43 in base 10. So I compile it. And we can see 43. Similarly, let's put Y and print out Y in base 10. And you can see that it gives 49. Okay, so what this shows is we're defining the int in binary. Okay, we're defining the int in hexadecimal here. Okay, and what you can see is I'm using that printed out to a string. Okay, so let's just do all of these operations. So let's do int a equals x shifted to the right by 1. Let's do int b equals x shifted to the left by 1. Let's do int c equals complement of x. Let's do int D equals, let's do X bitwise and Y. Let's do int E equals X bitwise or Y. And then let's do int F equals X bitwise exclusive or Y. Okay, and then we're going to print each of these out, okay, in base 2 to show that they work, okay. So let's see, we're going to do A, and we're going to do this for all of them. Okay, so B, C, D, E, F. Okay, so let's compile this. Oops. All right. So let's see. For the shift, when I shifted it 1 space, you can see that the output is 1, 0, 1, 0, 1. And I can see that that is indeed shifting this number 1 space to the right. Remember, the rightmost digit or the rightmost bit just gets thrown away. Okay. Here I shifted to the left by 1. Okay. All right. And hang on a second. And we can see that if I shift this to the left by 1, I'm going to pad it with a 0 on the rightmost bit. And I can see that that's exactly what happened right here. For the third line, it's the complement. And we have to be careful here. We get weird results because of 2's complement. So it doesn't, remember, negative numbers are represented as the leading bit is a 1, so it's giving me a weird result for that. So don't worry about that. We just won't worry about that. The bitwise and, you can check, is exactly like what we expected, okay? From just doing the math on paper. Same thing with the bitwise OR, and same thing with the bitwise XOR. So this gives us everything that we expect, with the exception of the 2's complement. It is complementing every bit, but it's interpreting it in the 2's complement way. So it's a little bit different, and we're not going to worry about that. I don't really feel like explaining it. Okay, so there is an assignment for the SL, Computer Science SL class called Bitwise. This assignment is only for the SL class. On Thursday, I will go over an assignment, or I'll do a lesson on what are called hash functions. And then after that lesson, there will be an assignment that is only for the HL students, okay? Both of these assignments are due on Monday of next week, okay? Remember, if you do not fill out attendance, you will be marked absent, and when your parents get a phone call that you were absent, then your parents are going to email attendance and say, but my my student was in class, and I'm going to say no, they didn't submit attendance. Okay, so please submit attendance. Thank you very much, and I will see you on Thursday.